resistor. Coming to the second one is an inductor. An inductor without initial current I0. So this is a symbol for an inductor. So initially when you close the switch, immediately that inductor will be act as an open circuit. It does not allow sudden changes in the current. So therefore, that inductor behaves like an open circuit initially, and at steady state, that is when the inductor fully charged, that time that the inductor can behaves like a short circuit. Suppose if you take an inductor with initial current, that is an inductor having some initial current, that time initially when you close the switch at t is equal to 0 plus, this inductor will be act as a current source with the same initial current, and at steady state condition, that is at final state, this inductor will be act as a short circuit in parallel with the same current source value. Coming to the capacitor. So capacitor can store the energy in the form of electric field, so that it is always depends upon the capacitor voltage. So here I am going to assume capacitor without V0. So when capacitor is turned on without V0 means the capacitor charge is 0. The time when you close the switch, immediately the capacitor behaves like a short circuit. So the capacitor can be replaced by a short circuit, and steady state condition means when the capacitor stores the full amount of energy, that time this capacitor behaves like an open circuit. This capacitor behaves like a open circuit at steady state condition. That is, capacitor can be replaced by open. When the same capacitor, the capacitor having some initial voltage V0, that time how the capacitor can behaves. So that time the capacitor can be behaves like this. That means the initial voltage V0 is in series with the short circuit, and at steady state same initial voltage V0 in series with the open circuit. Right, thank you. So the capacitor with the initial voltage can be replaced by an initial voltage even though if it is having initial voltage V0. So all of you please remember this table. Initially, what is the behavior of the element with and without initial voltage or initial current, and at steady state, what is the behavior of the element with and without current or voltage, whatever it is. So we have to remember two conditions, both for inductor and capacitor. How the inductor behaves like an open circuit in initial, and at steady state, what is the behavior of inductor? Similarly, capacitor. So that we have to remember that one. Now coming to the procedure for evaluating the initial conditions. So while solving the problems to evaluate initial conditions, then we need to follow some conceptual procedure. That means using this procedure only, we can evaluate initial conditions in any electrical circuit. So there is no unique procedure that must followed for solving initial conditions. Usually we solve for initial values of currents and voltages. An equivalent network of original network at t is equal to 0 plus is constructed according to the following rules. So here we are going to find an initial current, an initial voltage of any network, that too at t is equal to 0. So based on that we need to find. So what is the first one? Replace all the inductors with open circuits or with the current source having source current is equal to that of the flowing current at t is equal to t plus. So what he is going to say means when the switch is closed or opened at t is equal to 0 plus, then replace all the inductors with the open circuits. This is very, very important. So that we are going to replace all the inductors with open circuit at t is equal to 0 plus. Then replace all the capacitors with the short circuit or with the voltage source value of V is equal to Q0 by C if the initial charge is Q0. So in the previous table I told already, If it is an inductor with initial current, that we have to replace with the current source. If the capacitor with an initial charge, that can be replaced by the voltage source. That can be replaced by the voltage source. If the initial current is 0, no need to go to this one. If the initial voltage is 0, no need to go to this one. Directly you can replace capacitor by short circuit, inductor by open circuit. Now resistors. Resistors are left in the network without change because these resistors cannot include for the initial conditions or final conditions. No need to change. So the resistor remains same when the switch is closed or charging or at the end of the circuit also. So these are the important points we have to remember to evaluate initial conditions of any kind of network. So coming to the first one, I'm going to take a small problem with an examples. So here step 1, solve the initial values of variables, namely currents and voltages at t is equal to 0 plus. And step 2, we need to follow equal to 0 plus also. So these two based on the given problem. So based on the given problem only, we need to calculate. So that is what I'm going to explain. So I can go with a small example so that you can understand. Coming to this one. So first one. In the figure below, the switch is closed at t is equal to 0. Find the initial conditions I of 0 plus and d I of 0 plus by dt. So here he said, so we need to calculate first initial currents or initial voltages at t is equal to 0 plus. Later we need to calculate the initial derivatives of the variables at t is equal to 0 plus. So in the problem they can ask either I of 0 plus and d I of 0 plus by dt, or maybe d square I of 0 plus by dt square. That is always based on the given circuit. So this is a first order derivative current at initial. So how to find these variables or these currents for the given circuit? Let me explain. Consider a series RL circuit that is already given in the problem with the supply voltage is V, which is a battery here, that is plus or minus is indicated over here. And the switch, this is nothing but a switch, yes, and the arrow mark shows it is going to be closed at t is equal to 0 plus, at t is equal to 0 plus, at t is equal to 0 plus. Now an inductor and resistor which are connected in series, the current flowing through the circuit is I of t. Current flowing through the circuit is I of t. Now at t is equal to 0 plus, what is an equivalent circuit? So first we need to close the switch at t is equal to 0 plus. When I close the switch at t is equal to 0 plus, there is no change in the voltage. Voltage remains same. Now the switch is moved to position. That is, I am going to close this switch. This is a switch and it is to be closed. Now what is the behavior of the inductor initially? So go to the table. So what is the behavior of the inductor? So he has not, in that there is no initial current. So it is not mentioned. So that I can go with the second one. What is the inductor behavior at t is equal to 0 plus? That is when you close the switch immediately. So that inductor can be replaced by what? Open circuit.
Open circuit.
Therefore, this inductor, whatever the value, inductor over here, that can be replaced by open circuit. So there is no inductor. It behaves like an open circuit. And there is no change in the resistor. Resistance is to be same. It is independent of time t. Now what is the current in the circuit now? In this circuit, what is the current? So the current is nothing but I of t is equal to, what is the current in the circuit? If it is open circuit, because here it is open, there is no connection. If there is no connection, what is the current in the circuit? Can anybody please?
0, sir.
0. So therefore,
0.
I of t is equal to 0. Now we are calculating this condition at t is equal to 0 plus. Therefore, I can take this is I of 0 plus, I of 0 plus is equal to 0. So this inductor behaves like an open circuit and it becomes an open circuit. So in the open circuit, there is no current, the current is zero. So therefore, at t is equal to 0 plus, the current in the circuit is 0. Now what we do, because by applying KVL only, we can calculate this first order derivative of the current, because this is a first order circuit. How to define first order or second order or third order means based on number of energy storage elements in the given circuit. So generally energy storing elements are inductor and capacitor. In the given circuit, so it is a single element, so then I can call this is first order circuit. Suppose if there is a capacitor also, then I can call this is second order circuit. If there are more number of inductors and capacitors, that is based on the count, we can call the order of the system. So therefore, by applying KVL to the circuit, now after I am closing the switch, now the inductor starts charging. So there should be an inductor will be present for t greater than 0. T greater than 0. T is equal to 0 plus means at the closing instant only. For t greater than 0 means now the inductor starts the charging, like your mobile phone. Initially, when you put your mobile phone in the charging, then it shows 0. But after 1 second or 2 seconds or 3 seconds, whatever it is, the 5 seconds, now the your mobile will start charging. That is, I am going to assume for t greater than 0. So there should be an inductor for t greater than 0. So that we are going to take at t is equal to 0 plus, what is the behavior of the inductor, and at t greater than 0, what is the behavior of the inductor, at t is equal to infinity, what is the behavior of the inductor or capacitor. So these three conditions we have to remember. So how to remember means, when you take your mobile phone, when you put it in charging, at t is equal to 0 plus, the mobile phone charges 0. For t greater than 0 means, now the mobile phone starts charging. So it is the mobile phone charging in the sense, it is going to be increasing like this. At t is equal to infinity means that your mobile phone become 100% charging. So initial, during the transient, and this is the final. So that we have to remember these three cases only while describing any circuit. So for that, for t greater than 0, I'm going to apply, that is an inductor starts charging. Now for this condition only, I'm going to apply KVL to the circuit. So what is the KVL representation of the RL circuit? So generally V is equal to, now there should be an inductor. Therefore, the current, the voltage drop across the inductor is nothing but L into di by dt plus R into I of t. Now at t is equal to 0 plus, if I replace, because I am going to find this current only, first order derivative of the current in the RL circuit, at t is equal to 0 plus. So this is what we are going to find, I of 0 plus di of t divided by dt at t is equal to 0 plus only. Now replace at t is equal to 0 plus, now I will get L into di of t means 0 plus divided by dt plus R into I of 0 plus, R into I of 0 plus, which is equal to 0. What is the value of I of 0 plus? Initially, when you close the switch, that time the current in the circuit is 0. I of 0 plus is 0. Now replace I of 0 plus is equal to 0. Therefore, this value will become 0. Now what is the remaining value? So therefore, di by dt is equal to, there should be V and should be L. Therefore, I can have L into di of 0 plus di of 0 plus divided by dt is equal to V. So L, I'm going to take this in this side. That's why that's time di of 0 plus by dt is equal to V by L. Right, understand how to find I of 0 plus and first order derivative current di of 0 plus by dt. Any doubt? No response. Right? Can I repeat?
Yes, sir.
Okay, right. Very, very easy if it is understand. Otherwise, మీరు ఎంత ట్రై చేసినా సరే అర్థం కాదు. దట్ ఈస్ ట్రాన్సియెంట్స్ ఆఫ్ DC or AC circuits.
Repeat once, sir.
Right. I'm going to repeat now. Right. In the figure below, the switch is closed at t is equal to 0. Find the initial conditions I of 0 plus di of 0 plus by dt. What is di of 0 by dt in the sense it's a first order current in the circuit. But how to get this condition means, first we need to check whether the given circuit having energy storing elements or not. So based on number of energy storing elements, the order of the circuit can be characterized. Suppose if there is a one energy storing element, then I can call this is a first order circuit. If suppose there is a capacitor also included in the circuit, there are two energy storing elements, therefore I can call this is a second order circuit. So based on that only, we can decide either first order or second order circuit. So here only one inductor, therefore it is to be first order circuit only. Now we are going to find the currents I of 0 plus di of t by dt, that is at to t is equal to 0 plus. So this is what we are going to find, initial conditions. Now this is a given circuit. Now I'm going to replace, I'm going to close the switch at t is equal to 0 plus what is the circuit. So when you close the switch, when you move this switch, that is the switch is closed. When the switch is closed, let us assume this inductor will be a mobile phone. Let us assume this is your mobile phone with zero charge because they're not mentioned. So with zero current. At t is equal to 0, when you close the switch, what is your mobile charge immediately? Then అడిగిన క్వశ్చన్కి మీరు ఆన్సర్ చెప్తా ఉంటే దెన్ యూ కెన్ అండర్స్టాండ్ వాట్ ఈస్ యువర్ మొబైల్ ఫోన్ చార్జ్ ఇనిషియల్లీ వెన్ యూ క్లోజ్ ద స్విచ్ ఇమ్మీడియట్లీ
0, sir.
Right, 0. So when the mobile phone charge is 0 means I think no current is passing through this one initially. So that time this inductor will be act as a open circuit. So this is an inductor. You just assume me this is your mobile phone. So at t is equal to 0 plus, no current is passing through the circuit. Therefore, the current in the circuit is I of 0, that is I of t is equal to 0 because no current is passing. Now that to this current I have at t is equal to 0 plus. Therefore, I of 0 plus is equal to 0. That means when you close the switch immediately, that inductor does not allow the changes in the current. So I of 0 plus is equal to 0. That is clear. Now, after some time, we don't know the time I am going to take for t greater than 0. అంటే 0 seconds కన్నా ఎక్కువ కన్సిడర్ చేసినప్పుడు, that is for 1 second or 2 seconds or 3 seconds, 5 seconds, whatever, for t greater than 0. After some time, your mobile phone is not equal to 0. So the mobile phone charge may be gradually increasing like this, gradually increasing like that. So that time I can take this one. This is a time period condition while the inductor or capacitor charging for t greater than 0. Now I'm going to apply, that is this open circuit can be replaced by again an inductor will be there because it is in charging position now. This is only for t greater than 0. So we have to remember three conditions. For t is equal to 0 plus, t greater than 0, and at t is equal to infinity only. Right, for t greater than 0, this inductor starts charging. That means inductor will be present in the circuit. That time If you apply KVL to the circuit, what is the KVL? Kirchhoff voltage law. What says Kirchhoff voltage law? So algebraic sum of the voltages in any closed circuit is equal to 0. So this is a supply voltage. Now inductor voltage is VL. Now the resistor voltage is VR. Now what is the KVL says? I can take this as minus V plus inductor voltage is VL plus resistor voltage is VR and is equal to 0. Now what is V? V is equal to VL plus, that means inductor voltage and the resistor voltage VR. What is VL? VL is equal to, I can take this is current through the inductor. That means VL into voltage across the inductor is L into di of t by dt plus what is VR? I into R. Therefore, I of t into R. This is a supply voltage equation for t greater than 0. That is while the inductor starts charging. That is your mobile phone charging. That time this is a equation. Now, what is the condition I need to find? I'm going to substitute at t is equal to 0 plus only. I need to calculate. That time at t is equal to 0 plus means to have to substitute t is equal to 0 plus in the KVL equation. So what would happen? So when I substitute V t is equal to 0 plus in this equation, I can get V is equal to L into d by dt of I of, because I'm going to substitute t is equal to 0 plus. So I of 0 plus, that means t is equal to 0 plus R into I of t. Therefore, I can take this is I of 0 plus into R. What is I of 0 plus value in the previous? It is to be 0. That is 0. Therefore, what is the expression, remaining expression we are having? V is equal to L into di of 0 plus divided by dt, because this entire term will goes to 0. So therefore we are having only supply voltage is equal to inductance voltage. That means L into di of 0 plus by dt. What is the required value? So di of 0 plus by dt. So then what is this value? Therefore di of 0 plus by dt is nothing but, now I can write this is like this. So therefore V by L. So what is the first order derivative current in the circuit at t is equal to 0 plus means di of 0 plus by dt is equal to V by L. So this is a procedure how to calculate inductor voltage or current, whatever it is. This is a general procedure you need to find. And there should be one more condition, because we are going to find these currents at t is equal to 0 plus for t greater than 0, at t is equal to infinity. So remember, t is equal to infinity means it's a steady state value or final condition. That means your phone having 100% charging. That time, how the inductor can behave means go to the conditions. So at steady state means that inductor can be replaced by what? Short circuit. Therefore, that time this inductor will behave like a short circuit. Therefore, the remaining circuit I can draw over here at t is equal to infinity, because at t is equal to 0 plus is 0. At first order derivative current di of 0 plus by dt is equal to V by L. So that is already clear. Now I'm going to find what is the current in the circuit at t is equal to infinity. That is what I am going to find. So you have to remember three conditions. At t is equal to 0 plus, what is the current in the circuit? For t greater than 0, what is the current in the circuit? At t is equal to infinity, what is the current in the circuit? So if you know how to find these values, now it is very easy to understand the transient behavior of the electrical circuit. So what is next? I am going to find at t is equal to infinity, what is the circuit again? So same voltage source, the switch is closed for a long time. Now this is nothing but an inductor. This is nothing but resistor. So this is a voltage with the polarities plus and minus. This is a resistance value. Now current in the circuit is I of t. Right? Now at t is equal to infinity means it's steady state, that is fully charged. That time this inductor can be replaced by a short circuit. Therefore, the inductor can be replaced by a short circuit. It should be closed. Should be closed. That time, what is the current in the circuit now? Can anyone please? There is no inductor. It behaves like a short circuit. Then what is the current in the circuit by looking this circuit? Can anyone please? What circuit current in this figure?
IR.
What current I am asking? What is the current now?
0.
0 plus, sir.
Infinity, sir.
Look the circuit, find the current in the circuit now. There is no inductor.
V by R, sir.
Yes.
V by R.
Somebody says V by R. Very
by
good.
R.
Right. This is a current in the circuit at steady state condition because this inductor behaves like a short circuit. So when the inductor gets short circuited, the current in the circuit is only, we are having two values only. That's a source and resistor, V and R. That time the current I is equal to V by R. So we have to remember three types of circuits. Let me draw three types of circuits, then you can understand very easily. At t is equal to 0 plus, what is the circuit? For t greater than 0, what is the circuit? And at for t is equal to infinity, what is the circuit? So that you have to remember three conditions every time. So first one is at t is equal to 0 plus. At t is equal to 0 plus, how to replace the circuit? So there is no change in the voltage. That should be same. Now the switch is closed. This is a switch position. It is to be closed. That time this and this inductor behaves like an open circuit initially. Now the resistor, there is no change in the resistor. This R. Now this is an open circuit because the inductor behaves like an open circuit when you close the switch immediately. Now this is a supply voltage V. Now this is a current I of t in the given circuit. I of t in the given circuit. So what is I of t now for this circuit? For this circuit, what is I of t? Can anyone please? 0. Good.
0.
The current is 0 because it is open circuit initially. Now the second condition is I'm going to take, this is for t is equal to 0 plus. Now I'm going to take for t greater than 0. That means the inductor or the capacitor starts charging. That time the circuit can be replaced like this. The circuit can be replaced like this. So there is no change in the voltage. Voltage is to be same. Now again the switch is in on position. So this inductor again comes into the picture because it is going to be charged and there is no resistor value. This circuit L R and this is a supply voltage V plus minus. Now current in the circuit is I of t. So for t greater than 0, there should be present all the elements in the circuit. That means the inductor is present, resistor is present, whatever the elements are available, that are all elements should be present in the circuit for t greater than 0. That means the inductor now starts a charging for this condition. So that we have to remember this circuit like this. When the circuit is like this, what is KVL equation? This equation is the KVL equation. Supply voltage is equal to sum of the inductor voltage and resistor voltage. So what is an inductor voltage? L into dA by dt plus what is the resistor voltage? R into I of t. This is for t greater than 0. So for t greater than 0, remember all elements should be present in the circuit. Don't make as a open circuit or short circuit like that. For t greater than 0. That is in charging condition. Coming to the final condition. What is the final condition? At t is equal to infinity. That time at t is equal to infinity. Here I can draw. At t is equal to infinity. So there is no change in the voltage. That is to be same. Now the switch position remains same because it is always closed. Now this an inductor at steady state means that behaves like a short circuit as per our analysis. There is no change in the resistor. This is R. Now this is the current I of t in the given circuit, right? Now how this inductor behaves at steady state means it behaves like a short circuit. It behaves like a short circuit. There is no element. You simply join both the terminals with a wire. Now look at this circuit. So we are having only voltage and resistor only. Then what is the current for this circuit?
V by R.
V by R. So the current in the given circuit is V by R. Look at this one. At t is equal to 0 initially, the current in the circuit is 0. For t greater than 0, some current which is passing through the circuit, that is what we are going to find. But at t is equal to infinity, that inductor behaves like a short circuit. That is, the inductor got fully charged. That time, what is the current in the circuit is V by R. So, 3 conditions we need to calculate for every circuit. So that we have to remember this concept. At t is equal to 0 plus, for t greater than 0, at t is equal to infinity. Coming to the second problem. So this is the problem which is asked now. What we are going to find in the network. If t is equal to 0 plus, the switch K is closed. Find the values of I di by dt, d square I by dt square at t is equal to 0 plus for element values as follows. V is equal to 100 volts, R is equal to 1000 ohms, L is equal to 1 Henry. So we need to close this switch at t is equal to 0 position. Now what we are going to find I di by dt, d square I by dt square. These currents I of t, di of t by dt, d square I of t by dt square, and all these currents we can obtain at t is equal to 0 plus 1. So that for the values of V is equal to 100 volts, R is equal to 1000 ohms, and L is equal to 1 Henry. So V is equal to 100 volts. Now what is an R value? This is to be 1000 ohms, or you can make it as a 1 kilo ohm, whatever it is. So the R value is 1000. What is the L value is 1 Henry. Right. Coming to the circuit first. When t is equal to 0 means the switch is closed. Then just after closing the switch, the circuit becomes. So every time we have to draw the circuit. Then only you can understand how to behave the circuit like this. So when you close the switch immediately, what is the circuit means? Here I can draw. That means we are going to having 3 conditions. So what is the first condition is at t is equal to 0 plus. Now what is the second condition is for t greater than 0. So all elements should be present. At t is equal to infinity means whatever the elements in the circuit, maybe inductor or capacitor, can be replaced by the equivalent, either short circuit or open circuit, whatever it is. Now I'm going to find first at t is equal to 0 plus first. So at t is equal to 0 plus means, is there any change in the resistor?
No, sir.
No.
No. So here the switch, this is a K, which is closed. There is no change in the resistor. What about an inductor initially?
Open circuit.
It's a open circuit because when you close the switch, this inductor behaves like an open circuit. The inductor can be replaced by open circuit. If it is open circuit, what is the current in this circuit now?
0, sir.
0. So therefore, and it is to be 0 at t is equal to 0 plus, therefore I of 0 plus is equal to 0. This is for the first one. Coming to the next one. So apply KVL to the given circuit. Here I am going to take, now the inductor starts charging. So that I am going to apply KVL to the circuit. When you apply KVL to the circuit means there should be two elements should be present. So first one is what? Resistor. Later it is inductor. So both are comes into the picture. Now this is a current and this is a voltage. Now the resistor value is R, inductor value is L. So when you apply KVL to the circuit, we have V is equal to R into I plus L into di by dt. L into di by dt. So therefore, what is V? V already given in the problem, that is 100 volts. So therefore, I can take V is equal to 100 is equal to R into. Now, what is at t is equal to 0 plus? I am going to replace now. Now, R should be same. I of t can be replaced by I of 0 plus. L should be same. Di of t by dt means di of 0 plus by dt. This is what we are going to find now because I of 0 is calculated. Now I am going to calculate di of 0 plus by dt. So if I of 0 plus is nothing but what? This value is 0. So 0 into R is nothing but 0. So this entire value will become 0. What would be the remaining expression we are having? 100 is equal to L into di of 0 plus divided by dt. Now what is this value? Therefore, di of 0 plus divided by dt is equal to 100 by L. So what is the value of L? It is 1. So therefore, 100 by 1 is nothing but 1. Now what are the units? Units are always important. So in the numerator we are having current. In the denominator we are having time t. So the units for the given first order or second order, whatever it is, amperes per second. So the units for this current is amperes per second. So now substitute in these values. So finally I can get di of 0 by 0 plus divided by dt is equal to 100 amperes per second because the numerator consisting current I of t and the denominator consisting time t. Units for the current is amperes. Units for the time is seconds. Therefore, I can take this is 100 amperes per second. Now the second one is clear. So I of 0 plus is equal to 0. Di of 0 plus by dt is equal to 100 amperes per second. Now what we do next? And the third one, that is d square I of t by dt square. This is what we are going to find. We have only di of t by dt. Then how to get d square I of t by dt square? Is it possible? In the expression, if we have di of t by dt, can you get d square I of t by dt square from this expression? Right, differentiating this expression with respect to t on both the sides, right? So that we are going to differentiate this value in both the sides, right? This is equation number 1. Now I'm going to differentiate that equation in both the sides. Now what is d by dt of 100? From equation 1.
0.
What is d by dt of 100? 0.
0.
Good. Right, is equal to, what is the expression we are having? R into I of t. So therefore, there is a time function. Therefore, I can write R into di of t by dt because we are doing differentiation with respect to t. So therefore, d into I of t by dt plus. Now, what is differentiation of L into dA by dt again? When I do one more differentiation for this expression, what is the expression?
D square I
L
by
into, right, to d square d square I of t by dt square. D square I of t by dt square. Now I am going to substitute at t is equal to 0 plus values over here. So 0 is equal to R into d by dt of, sorry, d by dt of, what is the value I of t? So therefore I can replace t is equal to 0 plus I of 0 plus L into d square I of 0 plus divided by dt square. So 0 is equal to, again, R into, what is di of 0 plus by dt? What is this value? Already obtained in the first one, that is 100. Therefore, R into 100 plus L value is 1. So therefore, 1 into, again we are having d square I of 0 plus divided by dt square. So what happened now? We are going to calculate this one, that is d square I of 0 plus by dt square value only. So therefore, this value is equal to minus of R into 100 because we are sending this value into the left side of the expression. Therefore, I can have d square I of 0 plus divided by dt square is equal to minus of R into 100. What is the R value? It is 1000 into 100. Now, what is the total value? It should be 1 lakh. 1 lakh in the sense I can take 10 power 5. So therefore, minus 10 power 5. What are the units now? 2 times of current. So current is to be same. That is the amperes. It is square. So therefore, I can take the right ampere for second square. So these are the units. Understand?
Yes, sir.
Right. So we can find I of 0 plus in the given circuit, d I of 0 plus by dt. Also we can find, and also we can find the second order derivative current in the equation. But the second order derivative current we can find with the help of the KVL equation only. That is by applying one more time differentiation, then only we can get the second order current d square I of t by dt square. So this is the way how to find the initial values for a inductor circuit. Now there is a one more condition is left, that is at t is equal to infinity. So at t is equal to infinity, what is the current in the circuit?
V by R.
V by R. So at t is equal to infinity means that inductor behaves like a short circuit. So therefore, the circuit will become like this. This is a supply voltage. There is no change. The switch is closed. Now the resistor is same, but this inductor can be replaced by a short circuit. So this is nothing but an inductor, which is replaced by a short circuit. So this is an inductor. Now this is a resistor. what is the current in the circuit? I. So therefore, sometimes I can write I or I of t, both are same. So I of t is equal to what? V by R. What is the voltage? 100. What is the resistor value? 1000. So then what is the current? 0.1 amperes. So this is the current we can obtain at t is equal to infinity. So at t is equal to 0 plus, at t for t greater than 0. So remember the first order current or second order current, third order current, whatever the currents in the given circuit we can find with the help of the KVL. That KVL we can obtain for any circuit is for t greater than 0. So this is about problem. The remaining problems, that is, we are having one more problem is there for the capacitor. Then we are having for an inductor some more problems. I can explain all the problems. After that, I will go with the next concept. Okay. So request everyone, please refer the textbook to find the initial values or initial currents in the given RL circuit, or you can Google it. You can get number of circuit problems. So please try to solve the problems. In that, if you have any doubt, you please ask me. Then I can explain. Okay. Thank you.